So now when we're solving trig equations, paying attention to the range of answers that we want becomes important. Because if they say x is in between 0 and 2 pi, from that we can infer they want the answer in radians, not degrees. And if we were to give it in degrees, the answer would be wrong. But we still do the equation the same way. Sine x is minus root 3 on 2. We know it's in the third or the fourth quadrant. I work out my acute angle, but now it's pi on 3 rather than 60 degrees. And now instead of saying, oh, that's 180 plus, I'm saying it's pi plus, we still come up with two answers. So 4 pi on 3 and 5 pi on 3. So tan squared equals 3. Now it's plus or minus root 3. It means we're actually in all four quadrants. The acute angle for this one's pi on 3, but now we're in all four quadrants, so we get our four answers. We saw ones like this where, oh, hang on, that's all right. We'll turn it into a quadratic. What multiplies together to give -2 adds together to give 1. So now either cos x equals -2, well, clearly there's no solution to that because we know cos goes in between -1 and 1. So therefore we just want cos x equals 1, but they were our boundary values when we came to exact values. So I know it's either 0 or 2 pi. Remember, whenever you get 0 as a solution, 2 pi is also a solution, or 360 if we're talking about degrees. Very easy to miss one of those, but remember, you want both of the endpoints of the domain there. You want the 0 and you want the 2 pi as a possible answer as well. Oh yes, then we get ones where we could use our trig identities. So sec squared I can change to 1 plus tan squared. Again, I get a quadratic. That one factorised nicely as well. I get tan x equals minus a quarter. That one's not an exact value. It's all right. I still do it the same way. Now, sometimes they'll give me some sort of guide when it's not an exact value and they say do it to so many decimal places. If they don't, then I suppose I could just leave it as the inverse tan of a quarter. That would be an exact value. Maybe better to go 0.245 and then I'll mention, hey, I rounded it off to 3 decimal places or what have you. But anyway, I end up with 2 answers there. The other one is an exact value, so that's fine. Tan x equals 1. Of course, now the challenge is to put these 4 in order, because we like writing our answers in order. Which one's bigger? Pi on 4, 2.897, 6.038, or 5 pi on 4? Which one's the biggest? That's what I mean. It's really, remember, a radian actually is quite large. There's the correct order. It goes pi on 4, then 2.897, 5 pi on 4, then 6.038. Sine 2x equals 1 on root 2. Oh, okay. Well, if x is going between 0 and 2 pi, 2x is going between 0 and 4 pi. Right? Again, let's find our acute angle. It's pi on 4 for this one. 2x, but I'm going around twice, so I don't stop at pi on 4 and 3 pi on 4. I add on the other 2 answers as well. Add 2 pi to both of those. Divide everything by 2, we have our answers. It's all right. So as far as the actual solving of the equations, there's nothing different here. The only difference is how we're giving our answer. We're giving our answer in radians rather than degrees.